Dear students, today we shall discuss the next type of motor, that is vane motor. A rotary vane motor consists of circular chamber in which there is an eccentric rotor with sliding vanes in the slot provided on the rotor. The rotor is placed eccentrically with the housing. Fluid enters from the inlet port, rotates the rotor and thus torque is produced. So as you can see from the figure, the rotor, it is not placed at the center, but it is placed at some distance, at eccentric distance, as you can see in the figure. When the fluid enters from the inlet, there is some empty space for the oil to occupy. The rotary vanes, which is fixed on the circumference of the rotor, the length of these vanes can be variable. So by when the fluid rotates the rotor, the fluid moves from bottom position to topmost position, and from at the topmost position it leaves the motor through the outlet. So the flexible distance of the vanes, it causes the rotor to rotate continuously when the fluid is flowing. So this process happens continuously, and the continuous rotation of rotor is achieved. The displacement of vane motor, hydraulic motor, is function of eccentricity. The radial load on the shaft bearing of an unbalanced vane motor is also large because all its inlet pressure is on one side of the rotor. So here there will be inlet pressure acting on one side of the rotor, and hence there is some unbalance will be created in this vane motor when it is operating. So the next type of motor is balanced vane motor. So from the figure you can see that at inlet there are two ports, that is, it is like a T junction, and the fluid flowing through the inlet, it distributes in two paths. And in the rotor you can see that there is a eccentric shape on both the sides. So here in this type of motor, the rotor is present exactly at the center, and on both left side and right side there is some empty space. So when the oil is flowing, it occupies the right top empty space and left bottom empty space. So it makes the rotor to rotate in clockwise direction. Here also the vanes of the rotor can be, the length of the vanes is flexible, that is, it will increase when there is an empty space, and it will decrease when there is no empty space. So during this position, the fluid is moved from right top corner to right bottom corner, and at the same time it is moved from left bottom corner to left top corner. So during this position the rotor rotates continuously, causing the oil to flow to the outlet. And here due to the balancing of oil on both left and right side of the rotor, there will not be any unbalanced forces created on this type of motor, and the discharge of oil also is more when compared to vane motor, because in vane motor only one side oil will be created, oil will be passed, and in this type of motor the oil is passed from both the sides. So this is somewhat better when compared to the vane motors. So the balanced vane motor is reliable open loop control motor, but has more internal leakage than piston type motors. Next type of motor that we are going to look is piston motor. Piston motors are the most like their pump counterparts and incorporate only minor changes to effect the conversion. So they are classified as axial piston motors, radial piston motors. In axial piston motors there are two types: swash plate piston motor and bent axis piston motors. So we shall see what it is. First, we shall see the swash plate piston motor, or it is also called as axial plate motors. So here the piston reciprocates parallel to the axis of the cylinder block. These motors are available with both fixed and variable displacement features. So in the figure you can see that there is a swash plate, and on the swash plate many number of pistons will be attached on the circumference of the swash plate, and at the top valve is inlet valve, and the bottom valve present is outlet valve. When the swash plate is rotating inside the cylinder, The top valve, it will create some vacuum and it will suck the oil inside the um, pipe, and when it is rotating and when the same piston comes at the bottommost position, it will push the oil present towards the outlet valve, so that the rotation of the swash plate is continuously achieved. Again, at the piston present at top end, it will suck the oil, and when it is coming to the bottom end, again it will push the oil. So this process takes place continuously, and the rotation of swash plate also takes place continuously. Pressure acting on the ends of piston generate a force against an angled swash plate. So this causes cylinder block to rotate with a torque that is proportional to the area of pistons. The torque is also function of swash plate angle. If the offset angle is increased, the displacement and torque capacity increase, but the speed of the drive shaft decreases. Conversely, reducing the angle reduces the torque capability but increases the drive shaft speed. So the next type of piston is bent axis piston motors. So in the figure you can see that the axis of the piston is bent. It is not linear to the cylinder or rotating axis. So when this type of motor develops torque due to the pressure acting on the reciprocating piston. In this motor, the cylinder block and drive shaft mount at an angle to each other so that the force is exerted on the drive shaft flange. Speed and torque depend on the angle between the cylinder block and the drive shaft. The larger the angle, greater is the displacement and the torque, and the results in smaller speed. So this angle varies from 7.5 to 30 degrees. This type of motor is available in two types, namely fixed displacement type and variable displacement type. So in the figure you can see that this is also, here also the bent axis and swash plate, and the axis which is bent, it will rotate along with its axis. So when the top piston uh, is moving, it will create a empty space and it will suck the oil at the inlet position. The top valve is inlet port and bottom valve is outlet port. So again the same piston, when it is rotating and when it reaches the bottom valve, it will create the uh, it will decrease the space present and push the oil outside. So again when the piston is present at the top end, it will suck the oil, and when it is coming to the bottom end, it will push the oil. So this process takes place continuously and results in continuous rotation of the piston. Thank you guys.